Welcome to the Deep Dive, where we're taking a look at Antarctica, specifically how it became this fortress of ice.
And what's hiding underneath it all. We're going to get into the secret ecosystems, the hidden mountains.
And even how the land itself is starting to, well, fight back against the melt.
Right. And to get started, you have to appreciate the scale of the ice itself. I mean, it's just immense.
It's hard to even wrap your head around, isn't it?
It is. So we're talking about a solid continent, but it's buried under an average of 2.2 kilometers of ice.
2.2 kilometers on average.
Yeah, on average. And in some places, it gets down to almost 5 kilometers thick.
Wow.
And if all of that melted, you're looking at a global sea level rise of 58 meters.
58, that's staggering. But it wasn't always a frozen wasteland, right? It used to be part of Gondwana land.
Exactly. It was connected to South America, Africa. It was much warmer.
So what was the geological trigger? What flipped the switch? It wasn't just drifting south, was it?
No, that wasn't enough. The real tipping point was plate tectonics. It was the opening of the Drake Passage.
The gap between South America and Antarctica.
That's the one. When that opened up, somewhere between 30 and 50 million years ago, it changed everything.
Because it let the ocean currents completely rearrange themselves?
It let the Antarctic circumpolar current form, the ACC. It's the biggest deep current in the world. And because it can flow all the way around the pole with nothing in its way,
It creates a wall.
a perfect thermal barrier. It cut the continent off from all the warmer water from the north, and boom, that's what kicked off the Great Glaciation event around 33 million years ago.
So this massive current locked the ice in, and all that weight, it must have done something to the land underneath.
Oh, absolutely. It's called glacial isostatic depression. The sheer weight of the ice literally pushes the continent down into the mantle.
How far down are we talking?
Well, in some places, it's astonishing. There's a spot in West Antarctica, the Byrd subglacial basin. It's the lowest point on any continent on Earth, over 2,800 meters below sea level.
And it's not even ocean, it's just squashed land.
Exactly. But it's not all flat. We've also found entire mountain ranges down there, completely preserved,
Yeah.
like the Gomburtsev Mountains.
But the really dynamic part is the water, isn't it? There are hundreds of subglacial lakes.
At least 675 that we know of. And they're not static pools. They fill up, they drain, they're all interconnected.
And that water has to go somewhere.
It does. It acts as a lubricant at the base of the ice sheet. It reduces friction, and, that really speeds up how fast the ice flows towards the ocean.
Which of course brings us to the ultimate question. If you have liquid water, even trapped under 4 kilometers of ice, is there life?
Yes, absolutely. Not fish or anything like that, but microbial life.
Yeah.
Extremophiles.
So how do they survive with no sunlight?
They found another way. It's called chemolithoautotrophy, which is a mouthful.
It is.
It just means they get their energy from chemical reactions with the minerals in the rocks. They're basically eating rocks to survive.
So those headlines a while back about finding fish DNA in the ice cores, what was that?
That's where we have to be really cautious. Those claims are, well, they're highly disputed. The consensus is that it was most likely contamination from the drilling process.
Got it. So microbes are confirmed, but anything more complex is a no-go for now.
Right. But just finding these ecosystems is huge.
Because if it can happen here.
Exactly. These lakes are our best earthly analog for what might be happening on icy moons like Europa or Enceladus. They prove you don't need sunlight to have a complex ecosystem.
So to pull it all together, the continent's entire identity is really a product of plate tectonics creating that current.
It is. But here's the fascinating twist. The land is now pushing back.
What do you mean?
It's that same process, glacial isostatic adjustment, but in reverse. As the ice melts and the weight is removed, the land starts to rebound. It slowly rises up.
Like a sponge decompressing.
That's a great way to put it. And that rebound, that lift, is providing a really important negative feedback. It's actually helping to stabilize some of the most vulnerable parts of the West Antarctic ice sheet.
So the land itself is working against the melt, buying us time. Which leaves us with a final thought for you to explore. What happens when a continent begins to wake up?